Good afternoon and welcome to the second webinar of the Solar Show MENA series. Today's panel session will cover increasing efficiency in MENA with next generation PV. We are delighted to be joined by Issam El Sayed, Head of Solar Energy at the New and Renewable Energy Authority in Egypt, Christian Kalmas, Product Manager at Canadian Solar, Omar Sadr, who is the Business Development Lead at Yellow Door Energy. And the session will be moderated by Ian Kilbourne, an independent technical consultant from Canada. We invite all of our webinar attendees to ask questions for the panelists throughout the session, and we'll try to get around to as many questions as possible in the Q&A at the end of the session. Okay, so without further ado, I'll hand over to Ian. Take it away, Ian.
Hello, everybody, and welcome. I'm just going to begin by asking each of the panelists to introduce themselves. And before that, I will just summarize the topic a little bit. The topic is increasing efficiency in MENA with next generation PV. And so our intention here is to talk about some of the challenges that are coming with new technology and some of the opportunities. We're not going to strictly talk about efficiency in the sense of conversion of sunlight into electricity. The topic is broader than that, but it is intended to be about technology and not so much about other challenges in developing projects. We're going to stay with technology, not just PV, but the balance of system inverters. We can talk about that as well, with an emphasis on what's new and what's coming. So that's a quick summary of the topic, and I think our panelists are very well prepared and very well qualified to help us out with this. I'll just go across the screen here from left to right. So Issam, if you could please tell us a little bit about yourself.
Good morning. My name is Issam El Sayed. I am a manager of solar energy in New and Renewable Energy Authority. I start working in this field 2002. So I have experience more than 15 years in this field. Now I am in my way to be a general manager, so pray for me.
Thank you very much.
Thank you.
Are you in Cairo right now?
Yes, I'm in Cairo now, and we don't afraid a lot from coronavirus, but we have all the all the construction avoid this infection.
Yes. Okay. Good. And are you responsible? You're working for the Egyptian government, so are you responsible for purchasing and procuring solar developments?
Not 100%, but I am one of the team working in this field.
Right. Good. Was your background before you joined the government? Did you work in solar in the private sector?
We work only in the government, and we have a lot of projects. We give the special sector to participate in this field. As you remember, we have been done project with more than 2 giga in the field of PV, and yes, we have a lot of project in rooftop and so on.
Yes, good. Yes, I've been to Aswan. I'm a little bit familiar with the Ben project. Yeah, very good. Thank you.
Thank you.
We'll move on next to Omar with Yellow Door Energy. Omar, are you in Dubai? Hello, Omar. Yes, please go ahead, Omar, with your introduction.
Yeah, so my name is Omar Sadr. I work with Yellow Door Energy as a business development manager. Yellow Door Energy provides solar leasing and PPA solutions to commercial and industrial customers across the Middle East and Pakistan.
And yep, please tell us a little bit more about your projects, Omar.
So our projects are usually, so we're selling power to commercial industrial customers. We have customers like MAF Carrefour, Nestle, Unilever, we build solar plants for the customer, usually on site, where it's permitted to do net metering and so on, or off site, where we can take advantage of wheeling legislation, such as in Jordan. And what we do is we invest in the project, we build it for the customer, and we sell them power directly, so that they can benefit from solar energy.
Great. How long have you been doing this, Omer? That's fantastic.
So with Yellow Door, 4 years, but my journey in solar energy started in 2009 as an intern working on the 10 megawatt site in Abu Dhabi with Enviromena Power Systems. So that was a very long time ago. And since then, I worked with, I guess Christian would definitely know REC, the Norwegian solar energy panel manufacturer. In Singapore, where I was actually focusing on doing what they call CNI, commercial industrial solar in Asia. And since then, I've joined Yellow Door Energy to continue the commercial industrial dream that I've built during my time in Singapore.
Fantastic. Are you one of the owners of Yellow Door?
Let's say I'm one of the early members of Yellow Door.
Okay. Yeah. Very good. Thank you. Christian.
Oh, thank you, Ian. My name is Christian Gomez. I work for Canadian Solar as product manager. And I have been in the industry for many years now. I started in 2005, at the time at Sanyo, if you remember, the brand that changed into Panasonic some years later. And for a few years now, I've been working with Canadian Solar, one of the big five in the manufacturing of solar modules. My background is mostly technical. I've been doing sales activities all over the years sometimes going back more into the technical, but I am a fan of everything technological and technical. And actually, I've been doing stuff with bifacial since 2007. So this is kind of my favorite topic.
Good. And have you been involved in some projects in the MENA region?
Not in the project development. We are, as manufacturer, supplying to them, but helping the project people to optimize bifacial plants, for instance, is something that we actually do and where I have been involved directly.
Good. Thank you. Okay, well, we'll carry on with some questions. I guess I'm sorry. No, I'm going to start with you, Christian, with your background in bifacial. Certainly, bifacial is one of, if not the biggest, sort of disrupting technology that is moving through the industry. Hopefully, disrupting in a good way. So I know Christian has prepared a few slides that he can give our audience an introduction to bifacial and what does the technology really look like, and that will give us a good kicking off point. Thank you.
Okay, I will do it right away. So please let me know if you can see the screen right now.
We can see the screen.
Okay. So the idea is that things don't happen in a vacuum, and we don't do in photovoltaic anything just because of the love of the technology. Our goal, and in the MENA region, this is even more important than in other regions, is to reach very low levelized cost of electricity. Everybody has read almost every week that we are breaking records in the MENA region about how cheap electricity from solar can become. And this is the main driver for growth. So everything we do has to be related to improving, this means reducing LCOE. So we can change the technology of the solar cells, we can change the technology of the modules, the system technology, like how solar plants are made, and there's a fourth pillar about how everything works. It is the improvement, or at least keeping the very good reliability. So I want to take you through a very fast and very broad view about what's coming in all of these fields. About cell technologies, we live already in the time of PERC. I think the old technology that used to be called BSF, that dominated the industry, as just like 3 years ago was maybe 80% of the industry. Today is less than 10% of the industry, and everybody is doing PERC technologies. And this will remain like this for some time, we believe. But there are two new technologies coming up that are very interesting, and one is called TOPCon, and one is called heterojunction. TOPCon is a little bit of a further development of PERC, so this has probably the numbers to be earlier on the market for those players who already do PERC. But heterojunction itself has been on the market for many years. It is just that these two technologies have something in common, is that they perform better than PERC, but they cost more. Here I'm showing some graphics about what is the tendency of what's going on. Technologies like PERC are still improving. Every year we add 5, 10, even 15 watts of power for every kind of product, and not just us, all the competition, we all as an industry. And the cost is going down. This is, of course, the tendency that we all want to see. The products become better and the price becomes lower. In terms of new technologies like TOPCon and heterojunction, this is something quite interesting, because what is happening is that they start at a higher level of performance and higher level of cost. But that balance is not as good yet as PERC. This means the cost effectiveness, how to bring down LCOE, is not working with these newer technologies. If you make a system based on those new technologies, your LCOE will be worse as of today in most applications. There's always exceptions, so let's talk about the basics here. What is happening is that those two technologies are coming down in cost faster than PERC. The expectation is that in 1 year, 2 years, 3 years, those technologies having better performance in terms of efficiency and everything will be cost effective versus PERC. And that will be the moment where these new technologies will become mainstream. We don't know when that will happen, and actually we don't know if that will happen. Because for instance, in heterojunction, the one I know better, what is happening now is that the cost of materials has to be reduced. And in order to do that, it is very well possible that the efficiency will not be improving, because you will have to do some compromises in efficiency or low light performance in order to reduce the cost. So maybe it will be a flat line of efficiency, but a going down line of cost. And it is possible then, in the meantime, until the cost goes down to PERC, the efficiency of PERC becomes so much better that it reaches heterojunction levels. We just don't know. So everybody is keeping an eye open on this, and we are all, I think, talking as an industry, we are all open to all of the new technologies, and we are trying, and there's already products on the market of every one of these technologies, but they are probably just too expensive for normal big projects. If we think about module technology, I'm not going to read this, it becomes completely confusing. We have different cell sizes. New cell sizes are coming up. I have the feeling every week there's an announcement. We have different ways to cut the cells into 2 or maybe 3, maybe 6 pieces. All of that is already commercially available. We have different size of the modules, and every time a manufacturer brings a new size, they say it's the best, right? It's typically the biggest as well. So panels are getting bigger. So what is the reality? We will need to see. We have cell interconnections. We have bifacial modules, which is the main topic today probably. And we have different frames with and without crossbars, and so on and so on. It has become very difficult to see all the variety of technologies available and to judge what is the most adequate to a product, to a project. However, and this is something that I believe today is my main leitmotif, my main point. When you as a developer or EPC or generally as a customer want to make a project that has very low LCOE, very low cost of electricity, you need to know all of these technologies very close. You need to know the impact of each single parameter into your cost in order to judge which one of these products will be best for you. If you just follow rule of thumbs that were valid maybe 5 years ago or 2 years ago, you will do a system that is not optimized to your own purpose. And there's just an example. If you look at the very large tenders, they typically get awarded by very small differences in LCOE cost, in PPA value of electricity. If you do not optimize when you plan a system, you will not be the one winning as a developer. So this is driving the industry. This optimization is driving the industry, and how we call it is that there is no place to hide. This is what we say internally in our company. There is no place to hide. If you want to win, you need to know everything, judge your risk, and move forward. This is, for the industry, quite difficult, and I think today we will discuss about it. I'm not going to discuss every single point about this. I'm going to leave them a little bit on the screen so our attendees can take a look and maybe even make questions about those points, because this is open discussion. Should we do fixed tilt or tracking? Should it be 1P or 2P? Should we? All of this is very valid discussion that we can even have a bit today. We don't have too much time, but by keeping them on screen, you can afterwards take a look at the recording and see all the talking points. For me, as a closing sentence, if you are the CTO, the Chief Technological Officer of any company that is doing projects at any level, when you read these slides, you have to have very good knowledge of all of these things. And honestly speaking, it's a big change compared to just 3-4 years ago, where technologies were very standardized and everything looked the same. So that was the brief introduction. I hope I covered the cell technologies that are upcoming with more detail, and talking about system designs and anything else. I think bifacial is the hotspot for new developments. There is something else. This is floating PV. Personally, I'm not a big fan of floating PV, but it opens new places for PV that otherwise would not be used. So it has absolutely a market share that will be covered. And this is something where system design is improving very quickly, very rapidly improving in order to give reliability and more yield to those systems. That's the other big development, I would say, that we're seeing. So let me stop this. Ian, back to you.
Great. Thank you very much, Christian. Good. Let's move on to Assam. So Assam, in your position in Egypt, you're more on the purchaser's side than the developer's side. What do you see coming and in technology? What has changed recently, and what do you see in the next 5 years that is going to change the way that that you are looking at projects and purchasing?
Actually, as I work in New and Renewable Energy Authority, we have some political to protect the market from any kind of modules doesn't work correctly. So we must test all of the panels and inverter that come out from Egypt to protect the market. You see? So it's clear for all of us, the new generation of PV is less cost and high efficiency. So I can say it will increase the participation of the new generation of PV module in Egypt in the next 5 years. In 2 branches. The first one is the efficiency, high efficiency modules. Second, to have a 20% of renewable energy by 27. You know,
20% of renewable energy by what date?
2027.
2027. Okay.
Yes, not 20. It's 23%.
23%. Yeah. Okay.
Yes.
And now you said you were testing equipment to ensure that it is meeting standards. Is that correct?
Yes, the European standard and the Egyptian one. We have here in NAREA, New and Renewable Energy Authority, the modern testing facility that made by a company, a German company. It's 2020 production, you know?
Okay.
It's the modern one in the world.
So this is to test products that are manufactured in Egypt?
Yes.
Okay.
We import a lot of modules, a lot of inverter from China, from Europe, from America, from all the world. And we want to ensure that all of this product is working correctly. So we have some tests for aging, a long life for producing electricity from the module, and also the efficiency of the product itself.
Right.
I think we have more than 13 tests in BV lab.
Okay. And are you testing to standards that are developed in Egypt, or are you testing to international standards?
Both European standard, ISO standard, and Egyptian standard.
So you're doing this because you find that even though a product may claim that it meets, for instance, ISO standard, you find that in reality it might not, and so you have set up this lab to do this?
Sorry?
I'm just curious to understand if you purchase a product that is already says that it meets an international standard, for instance ISO, you are now testing those products again. Is that because you've had reliability problems?
Most of the modules and products import to Egypt is succeed in our testing, refer to according to the Egyptian and the European standard. We don't have a conflict between those standards.
Okay.
Did I answer you?
Yeah, I think so. Yep. Okay. And are you testing bifacial panels now?
Testing what?
Bifacial photovoltaics.
No, I don't know. I'm not the responsible about this lab. Okay. But I can send you a list of the modules that we can we test.
Right. Do you see bifacial as a technology that is going to overtake conventional PV panels?
Yes, I think so.
Yeah. Okay. And what about with respect to inverters and balance of system? Are there things that you're seeing there that are very new and different, or not so much?
I think the system is stable and succeed in our testing. So we give all of the systems that we test in, not all, most of the systems that we test in area a permission to going to the Egyptian market.
Okay.
So the new generation is a good product.
Good. Okay. Thank you. Let's move on to Omar. So Omar, as a developer and power, you're selling the power that your systems produce to your customers. What, as you look around for technology that is going to give you the best possible price that you can sell your power for, are you using bifacials now, and what do you see coming in the future?
Hi. So we have not used bifacial applications yet, but I mean, we have gone through a technology journey ourselves over the last few years. I'll give you a quick example. Yeah. One of our projects, actually a few of our projects, we had installed central inverters a while back. Now for the commercial industrial sector, we're seeing a big shift away from central inverters, more towards string inverters. This is obviously driven by what Christian was saying. I mean, LCOE is important, but due to when you're building a commercial industrial facility, it's a bit more difficult to get everything aligned to optimize for a central inverter as well. Plus, we look at the lifetime of the system when it comes to maintenance and so on, and we're seeing a lot of innovation happening on the string side, which has pushed us in that direction.
Can you just say, when you talk about a string inverter and a central inverter, where do you draw the line in terms of how many kilowatts or megawatts are we talking about here?
I mean, when we were looking at it at the beginning, we were looking at a megawatt as the threshold, but we're very far away from that. And to be quite frank, I think it would be quite difficult to find a project where we would prefer to use a central inverter today. But I'm happy to be challenged by the technical team on that. We'll have to look at the commercial benefits.
So when you use string inverters, are you using inverters as small as, for instance, 10 kilowatts, or more 50 or so? 50
would be maybe the starting point where we would start to think about this. Because our projects are usually 200 kilowatts to 20 megawatts in size, I think 50 is a good place to start. It's a very modular size as well.
Mm-hmm. Good. So you've moved, one of the changes just to summarize, one of the changes you've seen is that you've moved away from central inverters, coming into string inverters, although, larger string inverters, so 50 kilowatts and up. Yep. Any other changes that you've dealt with or that you see coming?
Well, to continue with Christian's comments, we've seen some good innovation on the technology side for panels with mono-PERC. This has really taken a very big step change in the LCOE of panels, especially as the experience develops. We've seen dramatic decreases in the cost of panels, and combined with overall reduction in the system costs, this has made solar energy very viable for commercial industrial customers. But I'd like to also applaud Nerea, to be frank, because they've taken on a few bifacial projects in the Aswan, in the Binban projects, and we're seeing, I think with time we'll start to see the effectiveness of bifacial in a very energy productive environment. So I'm excited to see what that will yield for the industry, especially because we are building larger scale projects in desert regions in Jordan. This could be an interesting learning for us as a commercial industrial developer. Would it make sense in the environments where we've been building larger scale? I mean, not larger scale in the same size as Binban, but in this up to 20 megawatt range. I'm very excited to see what the results will be. So thank you, Nerea, for helping us with that data.
Mm-hmm. Good.
Thank you.
Are you Omar, are you bidding right now on jobs? Are you winning work against bifacials, or is everybody still bidding monofacial panels?
So far it's been mostly mono facial panels. We have been exploring bifacial modules, but we haven't really found a very strong case yet. I mean, a lot of our projects are rooftop projects, right? And when you have glass applications, it starts to put a lot of weight on the rooftops. So, I mean, this becomes a challenge as well to consider, of course. So we'll see what the future looks like for the rooftops. And I mean, a lot of the opportunities we're looking at, for the bifacial when it comes to ground mount, we're seeing in Egypt some interesting bifacial projects. The question of operation and maintenance is something that we're looking to understand better as well. With time, I think we'll have a lot of data points to make bifacial a real success, because it is a step change in the performance of the solar plants.
Mm-hmm. Do you feel like you have the information you need to predict what the output will be of a bifacial system, either rooftop or ground mount, or is there a part of your hesitation? Is it just not being able to accurately predict exactly what you're going to get from it?
That's exactly it. We know theoretically, we've heard 19% increase in performance with bifacial panels, but I'd like to get a bit more details. In the Middle East, we have very tough environmental conditions, and that creates a lot of challenges. So, we will have to see what the results are. So, when Isam was talking about doing testing locally, I mean, this is a very valid point. We're talking about solar technology was prevalent in the past in countries that had developed countries where you had a lot of rain, you had different temperature conditions, different humidity conditions. And now, as we see solar start to flourish in the Middle East, we want to make sure that whatever products are being developed are able to withstand these tough conditions. We're talking as well about regional manufacturing considerations when it comes to band gap design and so on. This is another important consideration as well. So very excited to hear about the positive direction that the Egyptian market is taking as well.
Great, thank you. Let me just pitch that to Christian. There's many layers to answer the question, but if you're trying to sell modules to Omar, how can you help him predict what the output is going to be? What would you say the minimum improvement for a bifacial would be, and what are some of the things that have to be considered when you're considering do we go with bifacial on this project or mono conventional?
So that's a very good question and too long answer. So I will try not to answer that, but to give you a bit of hint. Basically, we do not see bifacial on the roofs as a benefit, with one exception, is if you want glass. You may want glass in any case because of the added protection to the cells, because the chemical compounds of the backsheets could have worse performance over the years in difficult climates compared to the glass, which is glass. So there is a case for bifacial, even if you do not get a single kilowatt hour more out of it, because the roof is a pitched roof and there's no space between the modules and there's nothing happening bifacially. Apart of that, what we see is that there is already ways to calculate very precisely the yield of bifacial. This is not something that has been possible for a long time. And it is a little bit already, or still a little bit of, I wouldn't call it secret, but kind of intellectual property of some companies. For instance, we have installed, I think, 12 sites all over the world in order to get data that helps us fine-tune simulations like PVCs in order to get actual results that match the simulations. I'm sure that many institutes and many independent consultants as well, but mostly institutes and large companies are doing similar things. So I believe that in a very short time, getting simulated results that get very close to the reality for bifacial should not be anymore a blocking point. In our case, we matched plus minus 1% of the simulation as the result on site. So for PVCs, that's pretty good, I think. Mm-hmm. So we are quite happy about that. It's something that should be very soon solved the issue. Mm-hmm. But bifacial doesn't happen in a vacuum. When you say that the climatic conditions in the MENA region are difficult, they're difficult for all modules. And things like soiling, things like how frequently I have to clean the panels, things like are my components going to withstand the heat? What is going to be the lifetime of the inverters? All of those things play a major role, and not just bifacial. I think that we will learn partly the hard way. about how the system configuration has to be made differently in the MENA region. And those who learn faster will definitely have an advantage on the field.
When it comes to operation and maintenance of bifacial, let's say you have a ground-mounted system in a desert-like environment, such as Binban. How do you? Presumably, you don't have to clean the backside as frequently as the top side, but can you speak to the O&M required?
So this is something that I'm willing to give some kind of assurance to anyone, because I think that individual experiences will trump general statements. From last year, I was visiting some customer, and I was very surprised because they told me that for tracking systems, they had to clean every single week. This means they had trucks of cleaning staff or robots or whatever going around the site all the time, because, well, they dimension the whole thing so that every module is cleaned once a week, because otherwise it's so many losses. Our experience is that the backside seems not to need specific cleaning. We have sites on desertic conditions that after 1.5 years of operation show no impact on the backside in terms of soiling. However, this is a single data point, and I'm a big enemy of taking single data points and judging that the whole world will work like that.
Yeah, good. I have a question from the participants. It says, what are the effects of the new technologies and continuous developments on energy yields? It's a two-part question, so that's the first part. If we just speak about bifacials and energy yields, what can we say about that? I'll start with you, Christian, since you're on the screen.
Okay, yields are getting better. That's clear, because that's the only way to go. This is now something that I want to develop a little bit more, this answer, because it sounds obvious and ridiculous.
Yeah.
Solar panels are getting cheaper. The moment that solar panels get cheaper, the yield, specifically speaking per kilowatt peak, becomes more important. So in the past, this was always important, but now it is being amplified. This means that when you make the numbers of how the performance of a panel is, if your performance is 1% better, your LCOE is not 1% better, it's much better. This means that there is a lot of interest in manufacturers, not just to reduce the cost, but to improve the performance. This means that if you have a bifacial system where your bifaciality gain is something like 5% to 10%, which is the realistic range that we think, we believe that things that go like 15, 20% is more marketing than reality, until or unless you do something with the soil that you get to increase the LP. If you're in this range, 5 to 10%, you can expect that your LCOE improves much more than that. So this is why in bifacial, or generally speaking, we're chasing this added performance with new technology. It's the only way to get that is with new technology, obviously.
I'll ask the other panelists the same question, I guess. Energy yields from new technologies, and we're talking about bifacial, but if there's anything else that comes to mind, the participant is asking, what can we expect in terms of improved energy yields going forwards? Hassan?
No.
Hassan, do you have any thoughts on this? Improved energy yields from new technology. What are you seeing?
Actually, I don't have a clear answer for this question.
Yeah. Okay, that's fine.
Sorry.
Omar, do you have anything to add to? Christian gave us a very good answer. Omar, do you have anything to add to that?
Yeah, so I agree with everything Christian said. Now, for us in our business, the cost of solar now has become competitive with the cost of energy at the meter for the customers, which is great because it's allowed the C&I space to flourish. So, but at the same time, by increasing the yields, we're able to cover more of the customer's energy needs. Let me explain why. Because currently, if we have a rooftop project, right, we are limited by the roof in terms of how much energy we can generate. So if we can generate 50% of the customer's energy today, maybe tomorrow we'll be able to generate 60 or 70. And ultimately, we'll be covering a larger portion of their energy consumption, which is great. Now, that is not the biggest factor driving the benefits to the integration of solar on the commercial industrial sector. It's coming from innovation in the financing space, which is bringing down the cost of capital, which is making solar even more competitive. Right? It's coming from innovative business models, which are also making solar more available to commercial industrial customers. Right? And so these are where we see a lot of innovations that are helping the C&I sector grow. Now, with regards to the second part of the question, which is there a plan in place to retrofit existing projects to these new, more efficient technologies? This is a valid question for the commercial industrial space. If I installed a solar installation 5 years ago, right, can I make the business decision to retrofit a customer's site to increase the yield? This is a decision that comes from what is the added benefit of installing new panels or technology versus the cost of this new investment, right? Is the customer better off just maintaining what he has in place, or is there any added value of this new investment, right? And I would say maybe today not yet, but probably in the future we'll start to see these added benefits, especially as customers start to seek more coverage from clean energy. So we'll wait and see if that will happen.
It would seem to me if the improvement of going with a bifacial is 5 to 10%, would be very hard to ever justify removing perfectly good monofacial panels and replacing them with bifacial to get a 5 to 10% improvement. Maybe when they're at the end of life, or if there's something else wrong with them. Christian, would you agree that retrofitting is not something we'll see, or do you think we will?
Retrofit depends on more on the legal part than the technical part. As of today, there are customers who have some kind of tariff where it can be attractive. If we are talking about own consumption, it is almost never a good idea unless the system is malfunctioning because of whatever reason.
Mm-hmm. So I'm not sure, I'm not understanding. You said there is a situation where you think that it could work?
So just imagine that you have a system, just imagine you have a system where you have a tariff that you get paid for the energy generation.
Yes.
Not that you use your own energy, but instead you're paid. And this tariff may be very high because you installed your system 15 years ago or 10 years ago. Yes. And at the time that was necessary. If your system has been paid back or close to that, new systems are so cost effective that that's just a small delta on that initial cost. And then the added performance is going to give you a boost.
Yes, okay, I understand. We have that situation here in Canada on some small systems. There was a very large feed-in tariff, approximately 6 or 7 times the cost of energy. And so those legacy systems still enjoy that high feed-in tariff. Yeah. And so perhaps a 10% improvement on them would be a lot of money. Yeah. Yeah. Another question from the participants here, while we're on bifacials, says, Do you think that bifacial modules are only good with tracking systems and they don't add much to fixed mount systems?
This is a very tough topic because there is no universal answer. You can get typically better bifacial gain with tracker systems, but it is not because of the tracker system itself. It's because a normal tracking system is maybe 1P. This means one panel in portrait turning around, so that you have a separation between the rows, because you need a lot of separation between the rows so that there is enough bright ground bringing back irradiance to your panel. If you think about what is the typical way to install fixed tilt, why fixed tilt is so cost effective, it's because you make tables that are very deep, maybe 2P, 3P, or 6H or whatever. But they are very flat, not very high because you don't want to make legs that are very tall. And those are the worst conditions for bifacial because you basically make a shed that is very dark below it. And then you get not a good bifacial gain. So if you want to optimize bifacial gain, then you need to make 1P. This means one row of panels. This is a way to install fixed tilt that nobody is doing because it's then nearly as expensive as a tracker. So this conundrum brings to the situation that when you have a site that is very expensive and you need, then you go to fixed tilt. And then the occupancy of the ground is much more maybe than 50%. Then there's these big tables and then some small space in between. The tables just to walk over or bring a machine or something. Those are not sites for bifacial. If you have a lot of land and you can separate the rows, but then you probably go to to tracking. So it is not. It is a very complex thing playing together. It's difficult to give just an answer and being truthful.
Yeah, I think that's a very good answer. It makes a lot of sense. Obviously, if in a conventional fixed mount system that's not tracked, there's very little light on the backside. And in order to take advantage of bifacial, we need to have that space to let the light in. And by the time you do that, then why not track as well? Yeah.
However, I want to make a last point about this is that not everything it is on the you have to take on face value. In a similar way, like Omar commented about the string inverters and Celtran inverters. You need to look at the whole lifetime of ownership. That's how LCOE should be well calculated, not just prices. Because it could be that something that looks less attractive like day one, maybe this fixed tilt, because of the simplicity, because of lower running cost, it becomes more interesting on the long term, like these string inverters that are easy to swap, easy to change, and it is a completely different animal, let's say. So it is more complex than just a 5-minute discussion. It is something that we always recommend our customers to simulate both options, regardless of whatever, simulate both fixed tilt and tracker for bifacial and see what comes up on top.
Very good, thank you. I'm going to jump to the next question from participants. It's a little difficult to understand completely. Panelists, I think you can see it. He's pitching it to Christian, but others may have comments too. Says, can you develop more the implementation of the bifacial PV for high capacity projects, 2,000 megawatt, I guess, and more? And what about hybridization with a CHP solution? Let's start with Christian.
So I think that any kind of large project needs a lot of land. It's pretty obvious again, Captain Obvious here again. But this means that they are typically developed in remote areas where land is cheap, because when you go to very high power for a project, you can take some transportation into the account and it's no big deal. So land typically is not the big issue for the very large projects. It is something easier. And when land is not the biggest cost, then bifacial wins. And this means, in our opinion, bifacial is going to be the winner of 90% or more of any energy auction that is large in the next couple of years until something new comes up.
Mm-hmm.
So this is something that answers the first part. And hybrid with CSP. I don't know if CSP is realistic in the MENA region with the lack of water, because CSP, as I know it, requires a lot of water. Maybe somebody knows more about that.
Could you define for the audience what CSP means?
Oh, sorry. CSP is concentrated solar. CSP is these things that you see in articles about photovoltaics when they have no idea about photovoltaics, when they put a big tower in the middle and mirrors facing that tower, and it's like 1965 idea of solar energy.
Yeah.
It used to be quite competitive until maybe 2010, where the prices dropped so much for photovoltaics, and all of those projects basically died, because this concentrated solar power is very good because you can heat up molten salts and then you can make electricity in the night, and that works very well. And if you have a lot of direct sunlight, the mirrors are kind of inexpensive, will reflect the light into the tower, so it all works more or less well. But the details are not so good, because as soon as there's a cloud, anything just doesn't work so well. And you need a lot of water to clean the mirrors, and mirrors have become nearly as expensive as solar panels today, which is kind of crazy, but it's the world we live today. So we don't see CSP as playing a major role unless there is breakthrough in terms of technology. We see much closer the possibility of hydrogen being generated from photovoltaic in order to keep this energy for the night. That seems to be like more a success story. In the MENA region, you have many countries with experience extraction and handling of gas. This means that you have infrastructure and a lot of know-how, and gas and hydrogen, they basically are brothers or cousins at least. So we don't see CSP as a big topic right now, but we could be wrong. This is just...
Yeah. So let me ask Assam, do you have experience with CSP in Egypt? And do you foresee building any more CSP?
Yes, I was a manager of MATS project from Nareya. It's a project financed by the European Union to build a big plant, concentrated solar power using carbonic fluff to generate 1 megawatt electricity, 1 megawatt hour, 1 megawatt peak electricity, and disseminate 250 cubic meter per day. And we have a Kuraimat, it's 140 megawatt peak. And I think our problem that we face, as my colleague said, Christian, it's the water. We need a lot of water to cool down the steam come out from the steam turbine. But it's a good project in all the region. I know Morocco have more than 4 projects. I think Karzazat, if you see about projects. Yes, we have a lot of solar radiation that we can rise up a temperature of water to 1000 degrees C, that we allow us to produce a famous steam to push the wind turbine, to push the steam turbine to generate electricity. It's stable, not related phase direct to solar radiation. In other words, if I have solar radiation in a photovoltaic panel, I have the same amount of electricity. But in case I don't have, I have a lot of heat energy stored in the system using concentrated solar power. This is the difference between PV and the concentrated solar power.
So we haven't talked at all about storage, and I see we're coming up to nearly an hour here, so it's a topic we could probably talk a lot more about than we have time. Just when you look at the market and the needs in Egypt, Assam, is energy storage at the top of your list, or are you more interested in just deploying lots and lots of PV to meet daytime loads?
Actually, in case we need to generate electricity to cover the base load, we can use a PV module. In another hand, if we want to store energy, we must use concentrated solar power. Concentrated solar power is not a rooftop project, as you know, it's a large project. We speak about 100 megawatt and up. In case of speak about concentrated solar power. But in case of we can use PV module, we can use the rooftop project 1 kilo to 1 mega. It's easy. So
right. Okay.
Your question is, do I prefer concentrated solar power with storage or PV panel? Is that your question?
My question really is, when you look at the needs of Egypt and the plans going forward, is storage something that is going to be very important, or do we have a long way to go just putting up PV to meet daytime loads and we don't have to worry about storage?
Actually, our plan, my point of view, is to work in both, not to depend on only one technology.
Right. So they're both
we increase using in the next 5 years.
good. I lost a little bit of that. Let's go to Omar, and just quickly, Omar, on the topic of storage. Do you foresee a lot of projects in the future where storage is going to be critical, or do you think that you have plenty of work to do just with meeting daytime loads?
So I definitely think it's a very important question in some of the markets where we're active and less important in other markets. Batteries, for example, in Jordan have become a priority as grid penetration from solar energy has become very strong. So we are looking at battery opportunities in certain markets where there's high solar penetration, where there is a lack of grid reliability. It's also becoming a viable option, especially for our commercial and industrial clients. You know, when the power cuts or goes through crazy fluctuations, this really affects their equipment. So having storage does create added value. And then finally, of course, we look at customers who are looking to maximize their consumption of energy from clean energy sources, who want to rely less on the grid. This is another case where solar and batteries become a more strong consideration for customers. So I do think that in markets where we have increased solar penetration, batteries are becoming more viable for the utility and grid operators. In countries where stability is an issue, we see that introducing batteries is now becoming a viable option as well, especially in markets with high electricity costs. And we always get inquiries from customers who don't want to deal with the utility, which is not always my favorite solution, because it does increase the cost of solar a lot to the customer. But with time, it's becoming more and more a viable solution.
Great, thank you. All right, we're arriving at 1 hour. Let me check in with Terrapin and see, is it time to close this webinar down? I don't have any more questions from the participants at the moment.
I would like then to make a comment about the battery storage. Mm-hmm. It is more a motivational speech, maybe, for all of those people in the industry. If you look at the energy cost in countries where energy is not heavily subsidized, where you have to pay for the material to burn, to make electricity, the transportation, and then for the last mile. You see that energy is costing something in between 12 and 30 US dollar cents per kilowatt hour. This is something that is normal. If you have a solar generation cost as of today of well below 10 cents, and in MENA well below 5 cents, and you add a cost for each kilowatt hour of the battery system, the moment that that kilowatt hour cost of battery system goes below 10 cents, you have an overall cost. As long as the sun is shining regularly enough that day and night and bad weeks and good weeks are kind of okay, where you run cheaper on battery plus solar than the existing system today. That opens a lot of business possibilities because many people in those regions have a lot of money and many do not. What that means is that many people can invest in that infrastructure and give energy as a service. This means daily payments for those people who don't have the cash to invest a lot, day one. But the other ones make a business out of having that cash and give the other people a clean, sustainable, and more affordable source of energy. And we believe that battery systems, because they are scalable, like solar, you can have this piece, you can have 10 of those pieces, and they're based on the same technology, like solar. Those are going to bring a revolution, and we believe that that's a big, big opportunity in the MENA region for many businesses to really have something new. And we're very excited about it. And we think that this is the next revolution after the digital and internet revolution, the energy revolution, where we will become independent. And we think that all those companies involved in that, they are gonna, if they work well, succeed tremendously. Competition is gonna be tough because everybody has access to the same building elements. But it's going to be really, I think, really good and really nice for everyone. So that was my motivational speech. If you didn't look at battery plus solar before, but you work in that environment, business environment, please do.
Good, thank you. I think all of us in the solar industry share your excitement for what lies ahead, and that makes a great bookend to bring to a close this webinar. I know that Malik is going to come on in a moment. I would just like to thank all of you. I think we've had a wonderful perspective from different parts of the industry, from Hassan, from Christian, and from Omar. You all bring very different experience to the table, and I hope that it's been great for the participants. I've certainly enjoyed hearing some very thoughtful things that you had to say, and I know that I've learned a lot. Malik, are you there?
Thank you, Ian, and thanks to all of our panelists for that insightful session. Well, that is the end of our second webinar of the series. Thank you all so much for joining. The webinar will be accessible via our website for on-demand viewing, and the link will be shared with you in the next day or two. If you do have any questions, please feel free to get in touch with us. We have our next webinar on June 11th, same time next week. So please make sure to register via our website. Thank you all again and have a great weekend. Bye-bye.
Thank you.
Bye-bye. Thanks, everybody.